stuck on that 12,000 year time period, end of the Clovis Age. Younger Dryas, beginning and end. That time period. And you said they had found mummies in this area. How far away was that?
5 miles.
5 miles, okay. And they reinterred them. You said that they estimated that the glaciers here were about a mile thick.
Mm-hmm.
Okay. So I learned about a little something about glacial and oceanic rebound, where the pressure of the glacier on the Earth's surface, when that glacier melted,
It's raising up.
created these uplifts. Could have created these uplifts. Because we had all that weight on here.
No, these uplifts predated the glacier on the Laramide.
Okay.
These were essentially at ocean level.
Right.
And then the Rocky Mountains uplifted through it.
Right.
So that was about 75 million years ago.
Okay. So
Laramide uplift.
So how is the uplift formed? this is what I'm trying to figure out.
The Rocky Mountains are a geological oddity in the fact that it's about the only mountain range that wasn't formed from one plate slipping under the other.
Right. Right.
It happened right in the middle of the continent.
Right.
And there's no
known plate.
no slippage of the plates. The plate is formed like this, and then the mountains tipped it up like that. But there's no answer on why it happened. Along like the Himalayas and other mountain ranges, they can explain it because one plate is slipping over the other.
Right. Yeah.
But it didn't happen in the Rocky Mountains.
Right. Not like California coast or the Atlantic Rift. Yeah. Greenland and all those other places. Okay. So how do they know when the uplift happened? How do they date that? Is it based on context? Is it based on, well, obviously it couldn't be,
It's a theory.
it's a theory. Okay.
There's no absolute proof that it was 75 million years ago.
Right.
It's not.
So, yeah, what I'm saying is they're basing it off of context. What they think the timeline is. I mean, the only way you can have any kind of accuracy is through carbon dating.
You can't carbon date it because.
Not that far back, yeah. So,
Well, no, because the Rockies aren't composed of one origin of magma. There's different batholiths, which are like bubbles in a lava lamp that had formed millions of years before the uplift.
sure.
And
Yeah.
they all floated together, and then they were all up, not all of them, but some of them were uplifted together. So, in this area we have a Sherman Hip batholith, Log Cabin batholith, Red Rock batholith, Silver Plume batholith. And they're all different.
So you got a number of them.
They're all different. They're identified because of the different predominant rocks that composed them.
Right. Okay. That makes sense. Well, I mean, we got a lot of that activity.
And the thing with that is that when these batholiths started cooling, the magnetic elements in them aligned north and south.
Right.
But when they analyzed that alignment,
Mm-hmm.
with the way they find them in the rock now,
Mm-hmm.
they don't all line, they don't
Right.
line north and south.
Right.
They,
Because North Pole and South Pole moves. Yeah.
well, also the batholith itself has moved around.
Sure. Mm-hmm.
The Sherman batholith, I read an article that said they think that it originated around the area where Japan is now.
Mm-hmm. Okay.
But it's all theory. There's
Right.
no proof to it.
Right.
You know, it's just like you can say, well, God made it to test our.
Exactly.
He
Yeah,
put those
right.
dinosaur bones there to test
our
us.
faith,
test
yeah.
Yeah.
Well,
Sure.
can you prove it wrong?
Well, no, I mean, but even, you know,
know.
relatively close to us, what is it? Is it Snake River, Idaho? Over to Washington. We know that there's been a lot of magma pockets, formations, over the years, and it's traveling west to east to what nowadays is Yosemite. But they know from the different kinds of rocks that they have around there that it was at different time periods,
Well,
right?
the caldera of Yellowstone,
Mm-hmm.
they have tracked it all the way from the Pacific coast,
Right.
clear across
Right.
Oregon,
Oregon,
Washington,
Idaho, Yep.
to where now it's Yellowstone,
Mm-hmm.
northern Wyoming and Montana.
Right. Yeah. So that kind of activity is always going on.
The earth is always moving,
Mm-hmm.
you know, and it hasn't stopped.
Mm-hmm.
You was talking about the weight of the glaciers on the surface of
Right.
the earth depressing it.
Mm-hmm.
So in the Great Lakes area,
Okay.
that area is slowly rebounding.
Right.
It's raising in elevation real minute fractions of inches.
Mhm.
Every year it's rebounding more.
Mm-hmm. Okay. And there's two basically glaciers in North America, right? One on the east coast and one on the west coast.
Seems like there's been 3 proven glacial periods.
Mm-hmm.
That's not right. But there are different glacial periods, more than 2,
Two different glacial fronts.
you know.
Okay.
And they happened, you know, it's a continuous cycle.
Mm-hmm.
The earth warms up and pretty geologically active,
Mm-hmm.
and then because of the geological activity it clouds the sun,
Okay.
cools the temperature of the earth,
Mm-hmm.
and it allows the formation of glaciers.
Okay. Right.
Then once the sun is not clouded,
Mm-hmm.
then it starts warming up again and the glaciers melt and retreat, then it all happens over again.
Yeah.
So we're still in a glacier period
Mm-hmm.
because the glaciers in Greenland and Glacier National Park, and they are from previous ice age that has not melted yet. So we're still in an ice age
Right.
until they melt.
And that's good because that's why we have ice core data now. So.
But they're not accurate.
Right. So.
You can't date ice cores.
But you can fudge it.
Yeah, that's
You can
that's a
fudge.
good point.
Yeah, but you can fudge it.
Yeah.
Fudge the numbers enough.
Oh, fudge it.
Yeah, fudge it.
Yep.
Because glaciers don't form at an annual rate.
Right. It's over eons.
Even at the end, they don't form at an annual rate.
Okay, then I'm not understanding what you're saying. What do you mean by an annual rate?
You can't
I see.
core drill
They're
down.
core drilling and giving it an
And you
annual
can't
date,
say, okay, this is
like a
50,
tree ring. Yeah.
this is last year, this is next year, this is...
Thank you. That's important information to have.
Tree rings are not
Right.
correct either,
Mm. Oh, really?
not in my opinion.
Uh huh.
Because I've cut down trees like the lodgepole,
Mm
which, you know, this big around, and count the rings on them.
hmm. Mm hmm.
And the next tree that's this big around, you count the rings on them, and they don't correspond.
Mm hmm.
They don't have the same number of
The same
rings.
number of rings.
They can be off as much as 100 rings.
So why did they give us?
Wow.
Why did they tell us this? Why do they tell us that when they're doing ice core drilling, they can tell what happens each year? Why do they do it with tree rings?
Because they're assumptions.
Thank you. Because we were talking about that
Yep.
on our way over here.
Yep.
It's
Our whole. Another question I have for you is charcoal layers. Have you found any up here?
what?
Charcoal layers, layers of charcoal that have been buried.
Yeah.
Yeah, where approximately.
Well, up on the ranch, there's a wash happened less than 100 years ago.
Mm-hmm.
And it uncovered different layers of charcoal.
Mm-hmm.
Most of them were either cooking pits
Mm-hmm.
or heating surface
Mm-hmm.
fires to keep warm with. But it,
So you found a settlement site.
the layer of dirt is around 40 foot thick
Mhm.
where the wash went through,
Mm-hmm.
30 foot, 40 foot, somewhere in there.
Okay.
And you can find it it's on a shelf of sandstone,
Mm-hmm.
and you can find layers about this far up from the sandstone, clear
Mhm.
up to the surface, just about this far below the surface, and you'll find it. And so
40 feet down.
it's not the result of natural activity.
Mm-hmm.
You know,
Man-made.
a
Coke-
cook pit,
Coke ovens?
a cook pit, they'll dig a hole
Mm-hmm.
and you line it with rock,
Right, but not 40 feet down.
and then you get a fire going and you get the hot rock real hot,
Right.
and you take the coals out
Mm-hmm.
and you put your seeds in there
Mhm.
that you've gathered, and you cover it over and let it sit for several days.
Okay.
And the heat from the rocks cook the seeds.
Correct.
So then you have this, you know, like maybe a 5-gallon bucket full of cooked seeds.
Mm-hmm.
So that doesn't happen naturally.
No.
You won't find a
Right.
lined cook pit.
Okay. And
And then the reason why I say they were heating fires is because they're a small area, you know, less than the size of this table.
mm-hmm.
Just a pocket of
Yeah, it's just a small.
ash
Yeah.
on
Okay.
top of the ground that was done on top of the ground.
Mm-hmm.
And then it got covered over with wind-blown dirt.
Okay. Because what they're finding is multiple places all up and down the southwest on over to here where it drops off again, of what's called black mat, which is charcoal and algae that was then covered with water, and underneath that they're finding tektites, nanodiamonds, microfarads, iridium, platinum, things of this nature, just below that charcoal layer. And if it happened in Clovis, New Mexico only, but they're not finding that where they're doing excavating you know, they're archaeologically they're doing excavating. But they found that this is something that was common that they were finding all over the place, and it kind of forms this band of about 1,000 miles wide. You know, straight up the southwest, all the way up into Canada. So that's what I'm looking for, is if we can find charcoal layers, I would like to find those tektites. So,
Me too.
and this is a just prove something to me thing, but I would like to find those tektites, and if it is platinum and iridium, that adds another layer of mystery. So,
Well, what you're talking about, there's a layer, and they attribute it to the meteor that
Right.
hit in the Yucatan or Yucatan Peninsula.
yeah, at the end of the Younger Dryas, yeah. And the Gulf of Mexico. Yep. And I'm hearing now that they say that meteor shower lasted for 21 years, that activity, but that is based upon ice core samples. So, okay, so we already talked about that. I haven't been able to wrap my head around the 21 years yet.
I don't know how they can, was it,
Carbon
you know,
in the ice samples.
it's just an assumption.
Yeah, exactly. At what date they say it is. So, okay, so we're looking at more fudge factors.
Scientists. I'm a real scientist.
Okay, yeah, I would like to find those charcoal samples and
I think
see if I can find the platinum, iridium, and tektites.
I think our area here, you wouldn't find it because one thing was the melting of the glaciers
Right.
13,000 years ago,
Right,
and how it changed everything.
right. The whole landscape.
You know,
And isn't that how the alluvial plain to the east built up, was from all that glacier melt?
it had a contributing factor to it,
Mm-hmm.
and a lot of it predated the Laramide uplift.
Mm-hmm. Predated. Okay.
So I've read articles that said that before the Laramie or the Rocky Mountains come up running north and south,
Mm-hmm.
there was a mountain range that run east and west, and that had a contributing factor to the difference in climate.
Okay. East and west, and where was that located at?
And Cheyenne Ridge is the remains of it.
Cheyenne Ridge is the remains of it.
That's what I've read. I mean, I can't prove it. I wasn't here.
That's the whole problem with trying to understand how we got where we are, is none of us were there. None of us.
No.
None of the
And
scientists.
none of it is
Yeah.
settled. Anytime somebody tells you that's the science period, the science is settled,
They turned science into
they're a
religion.
priest, not
Yeah.
a scientist.
Exactly.
Yep.
And didn't I cover that in the,
You
the
did,
last
you
episode?
did.
So.
That's why we just have to ask the Hopis.
Yeah. Yep. Okay.